Insultec is a remarkable material, and extensive test results have proven this beyond any doubt. But what is it that makes this membrane so incredible, and what are the property principles behind it? Firstly, insultec is comprised of specially developed pigments that interact and bond in such a way they repel heat. The principle is not unlike a mirror, hence this pigment bonding is preventative to heat and not reactionary. Taking a normal substance such as galvanized steel reaction to solar heat is fairly standard. Basically, the sun's rays impact upon the surface of the galvanized sheet, reacting in two forms. Firstly, of the 100% solar rays impacting on the surface, 71% are immediately reflected. The remaining 29% are absorbed into the material. Whilst inside the thickness of the galvanized steel, the solar heat rays retract and collide, heating up the material continually. The material retains some of this heat energy, whilst also re-radiating out a small percentage and, importantly, transmitting this heat inwards. An average of 23% of solar heat is transmitted through the galvanized steel sheet, causing increased heat on the opposing face and heating the air behind. Conversely, galvanized steel coated with the insultec membrane acts in a different way. When the solar heat rays impact on the membrane, a significant percentage of heat is immediately reflected. An average of 85% of solar heat is reflected into the atmosphere. The remaining 15% is absorbed into the membrane and reflects and collides with the product interacting with the insultec pigments. The properties of these unique pigments then cause an astonishing 95% of the absorbed heat to radiate outwards into the atmosphere. That is approximately 14%. The remaining 1% of absorbed heat then slowly permeates into the galvanized steel to once again react and collide with the material before a small percentage manages to transmit inwards. Therefore, the amount of heat transferred from the surface of the insultec-coated substrate is far less. In studies conducted by VIPAC and the University of Western Australia, an enclosure constructed from galvanized steel would gain 47% more heat than an identical enclosure coated with insultec. Insultec's remarkable properties greatly reduces heat gain when applied to all materials, outstripping other material by a minimum of 100%. Here are some further supportive figures. These are conventional figures of merit in relation to solar heat gain, showing insultec's performance against various commercial roofing materials. All of these tests were conducted under ASHRAE specified test conditions. Insultec. The hotter it gets, the better it works.